Here we are on to the next problem, which is related to three-dimensional geometry. What is given here is, if the length of the perpendicular from the point beta comma 0 comma beta to the line is root 3 by 2, then the beta is equal to. So, what is given to us here, you can understand that there is a point, and from this point the distance to this line, the line is this distance is root 3 by 2, and this point is beta comma 0 comma beta. Now, we want to find out the value of beta. Now, let us say this point is A and this is P. Now, assuming any point on this line in a single variable is important, and we know if I substitute here P, then I can calculate x from here. Now, x will be equal to P. What will be y? Y will be equal to 1. And what will be z? Z will be equal to minus P minus 1. Now, this is a variable point which is lying on this line. Now, what is given? That AP is perpendicular to this line. So, definitely we will calculate the dot product of AP and this line, that is the direction cosines, we need to find out here. So, what we are going to do here, we will find out the direction ratios of this line, which are equal to P minus beta, again 1 minus 0, and again it is minus P minus 1 minus beta. Now, these are the direction cosines, direction ratios of AP, and again I am going to calculate the direction ratios of this line which are given to us, that is 1, 0 and minus 1. Now, you know, if the angle between these two lines is 90 degree, then the dot product will be 0, or we have here this into 1 plus this is 1 into 0, and again minus P minus 1 minus beta into minus 1, this is equal to 0. Now, from here we have the beta will cancel out, as you know, and again 2P plus 1 is equal to 0. So, from here we can calculate the value of P. So, definitely the value of P from here is minus 1 by 2. So, now this point is known to us, it is minus half comma 1 comma minus 1 by 2. Now, P is known to us. Now, the distance we haven't used. Now, what is the distance? Distance is root of 3 by 2. Now, what we are going to do here, we will equate the distance between these 2 points, that is beta plus 1 by 2 whole square, and again 0 minus 1 whole square, and again we have beta plus 1 by 2 whole square, that is equal to 3 by 2. Now, calculating the value of beta from here, this will give you beta will be equal to 0 or minus 1. So, let us see which option is correct for us. The option which is correct is option number 1. Now, let us see another problem. Next problem is related to limit as a definite integral. You can see here n is tending to infinity, and there is a series out here which is again going to infinity. So, the number of terms here are infinite. So, it is very much clear from here this limit is to be converted into a definite integral. So, let us see the general term of this limit as first. You can see the general term is n plus r raised to the power 1 by 3 upon n into n raised to the power 1 by 3. Now, sigma the first term, definitely the r will start from 1 and it will move up to n. So, this is actually the problem for us where limit n is tending to infinity. Now, what we are going to do here, I am replacing r by n with x such that 1 by n will be a small quantity which can be treated as dx. Now, you can see this entire limit will be converted into a definite integral. So, let us see what we will have here. From here you can see that this can be written as r by n 1 plus raised to the power 1 by 3 into 1 by n. So, replacing r by n with x, we have 1 plus x raised to the power 1 by 3 and 1 by n will be definitely dx. So, what are the limits here? You know r is equal to 1. When r is equal to 1, so x will be tending to 0 and we are going up to n. So, definitely at n x will be tending to 1. So, this is the definite integral for us and we know how to evaluate it. We have here 1 plus x raised to the power 4 by 3 upon 4 by 3 and definitely putting the limits from 0 to 1, you will get the second option as the correct option. Let us move on to the next problem. The next question is from circles. What is given here? The line x equal to y touches a circle at the point 1 comma 1. If the circle also passes through the point 1 comma minus 3, then the radius is. Now, this concept, the concept of point circle is here, a very important one. So, let us understand what is given to us. We are given a circle and again there is a line for us, or you can say a tangent here, which is touching this circle at the point it is given 1 comma 1 and this circle is passing through 1 comma minus 3. So, this is the point through which the circle is passing. So, what we can have from here, this is a tangent. The tangent is definitely y minus x equal to 0. Now, what we are going to do, we are going to apply the concept of family of circle. What I am going to do here is, I am treating this point as a circle which is known as point circle. That means its radius is 0. So, I am writing this point circle, that is x minus 1 whole square plus y minus 1 whole square equal to 0. Now, this is a line, that is y minus x equal to 0. Now, any circle which is passing through this point and this line, that is the intersection of this point and this line, are infinite and this is one of the circle. So, all the circle which are actually passing through or which are touching this line, that is y equal to x at 1 comma 1, can be given as s plus lambda l equal to 0. Now, the s for us is this one. This is s and this is definitely l. So, these are all the family of circles which are passing through this point, or you can say the tangent is y is equal to x at this particular point. Now, we need to find out lambda. You can see there are infinite circle. For a particular lambda you will get this circle and for different lambda you will get another circle. Now, we need this circle which is passing through 1 comma minus 3. So, what we are going to do here, we are satisfying this point here and for that we will get a particular value of lambda. So, putting this value 1 comma minus 3 here, this will make it 0 and from here we have minus 3 minus 1 whole square and again from here we have minus 3 minus 1 equal to 0. Now, calculating this, you can see lambda from here equal to 4. So, the circle we are having here is x minus 1 whole square y minus 1 whole square plus 4 y minus x. Now if we expand this, we have the required circle and we can get the radius, which will come out to be 2 root 2. So definitely the option which is correct is definitely the third option. Let us move on to the next problem.